linear and quadratic systems. Now, what are those? They are a set of equations, and to solve one is to find when both of them are true. But a better way to understand that is on a graph, right? We plot out these equations, right? So maybe there's a linear equation like this, and then we have a quadratic equation like this, right? Now, what it means when both of them are true is the intersection points here and here, right? Because the x and y on both of them are the exact same, which means that it's true. But now I'm going to teach you how to solve for these. Let's start off with a simple linear system of equations. And now all we got to do is something called substitution, right? And we need the y to equal to y and the x to equal to x, right? So, y equals y, right? If y equals y, right, and this equals this, right, we could just replace or substitute these two values with this. So it could be x plus 2 equals 3x, right? Then just bring everything over to one side. So let's subtract x and subtract 2 from both sides. And then we're left with 3x minus 2 equals 0, which is just 2x minus 2, right? And then we just simplify that a little bit more, and we get 2x equals 2, x equals 1. So the x coordinate of where they intersect is at 1. Now we got to find the y coordinate. And we can easily do that by plugging in the x value into each one, right? So y is equal to 1 plus 2, and then y is equal to 3 times 1, both equaling 3. That's essentially how substitution works. It's super easy. And now we know that at 1, 3, at those coordinates, these two equations intersect. Okay, this one is a linear quadratic system. Same thing, just x squared plus 3x plus 2 is equal to x plus 2. Subtract everything on this side, bring over here, that would just be x squared plus 2x, and these two cancel out, equals 0, right? Now what we can do is something, we can just pull out a factor, right? Both of these have an x in it, so we can do x plus 2, right? You see how this multiplies out to this, and that equals 0, right? Now, we just got to find out when both of these are true, right? So if x equals -2, this equation will make 0, and if x is just 0 here, it would also make it 0, right? So that means the x-axis of where both of these intercept, or the x point, is just going to be at 0 or -2. Now we just plug that right back into the equation and do that. And also, I'd recommend you do it for every single one. So plug this in here, and plug this in here, plug this in here, and plug this in here, right? Just to be safe, on a test and stuff. But yeah, so y is equal to 0 plus 2. So that means it's going to be 2, or it equals 0. All right, so it's going to intersect at the origin point. So let's just write those chords down. So 0, 2, and then 2. Oh, whoops. I'm not even recording that. -2, 0. And let's try that for this one, right? So if it's 0, right? So y equals 0 squared plus 3, 0 times 0 plus 2, right? So it's just also going to be 0, 2. And then let's try -2. So -2 squared is 4 plus 3 times 2, which is going to be 6, or -6. -6 plus 2, which is also going to be 0. So when it's -2, it's also 0. See how that works? It's pretty neat, yeah? Okay, now quadratic. This is the same thing again. Just x squared minus x minus 6 is equal to -x squared plus 5x minus 6. Then bring everything over here. So 2x squared minus 6x minus 6 minus 6. So it's just going to be cancel out. It's going to be 0. Right. Now, honestly, the most difficult part of this is just solving for x. But you don't need to worry about that if you know the quadratic equation, and you can just plug this in here. And I'm just going to do this because I got it wrong in the last video. So minus b plus minus the square root of b squared minus 4ac over 2a. Okay? So now just plug those numbers in. This is technically a quadratic equation. So this value here is a, this is b, and c is not existent. So it's just going to be 0. Right? So, yeah. Oh my god. So 6 plus minus the square root of -6 squared, which is just going to be 36, minus all of this multiplies to 0, so it's just going to be 0, right? Because c has no value, and that 0 times anything is just 0. Then divided by 2a, which is just going to be 4, right? So now the square root of 36 is 6. So we have 6 plus minus 6 divided by 4. Right now, if it's 6 plus 6, right, That's going to be 12 divided by 4, which is just going to be 3, which is x. So let's move that up here. X equals 3. And then if it is minus, then it's just going to be 0. So 0. So those are the chords of x where they intercept. Now we just plug that right back in. And if for the first one, if it's 3, we get 3 squared minus 3 minus 6, which is just going to be 9. 9 minus 3 minus 6, which is just 0. Right? So the chords would be 3 comma 0. And then if it's 0, then it's just going to be minus 6, right? So it's just going to be 0 comma minus 6. Right, now let's put those same numbers in for the rest of them. If it is 3, so that's just going to be negative 3 squared, so that's going to be negative 9. Where's my eraser? So negative 9 plus 15 minus 6, it's just going to be 0, so it's going to be 3, 0 again. And then if it's 0, it's going to be negative 6 again, so it's just going to be 0, negative 6. And yeah, that's how that works. It's pretty easy, yeah? Now here's another way, sometimes easier way, for you to solve, you know, a system, right? This one's pretty simple, right? But what I was teaching you before is substitution, where you substitute a value for a value that you already know, right? Like each time there, we substitute y with the value of y, which was the equation. But here, instead of just like isolating y and then doing substitution, doing all that, it's much easier if we do something called elimination, right? Where if we add these two equations together, right, we get 6x, and then these two cancel out, is equal to 18. And then we can just divide by 6, x is equal to 3, and then we can just plug that right back into the equation, right? So 6 plus 3y is equal to 12, right? And then 3y is equal to 6, y equals 2. So that means the chords are 3 comma 2. And if you plug that into this one, right, it's going to be 12 minus 3y is equal to 6, right? Minus 3y is equal to negative 6. Y, if you divide by negative 3, is equal to 2, which is going to be 3 comma 2 as well. That's also super simple. Okay, so sometimes you're going to come across like some equations that never intersect, like these two. These will never intersect at any point, right? So what's that going to look like towards the end? Well, this is an equation that's never going to intersect. And if I go through all of it, I'm going to end up with an imaginary number, right? So x is going to be equal to a square root of a negative number, something like that, right? Which isn't possible on this sort of graph, right? So what can you do to like stop you from doing all of that work and finding out that there's no solutions? Or if the question is just asking you how many solutions there are, there could be 1, there could be 2, there could be infinite many, or there could be 0, right? So the easiest way that I'd recommend is just plug it into your calculator and look at the graph, right? However, if you don't want to do that, you can look at something called the discriminant. That is the discriminant, right? And if it equals 0, that means there's only one solution, or one point where they touch. So it's like a tangent, you know? Well, right? If there's 2, that means they touch in 2 points. Boom, boom, right? And if there's none, they never touch at all, right? So let's do that for this equation, right? So first things first, it has to be in quadratic form, and you have to substitute it, right? So let's first do some substitution, right? So x squared plus 1 equals negative 2x minus 5. Bring everything over here. 2x squared minus, or plus 2x, and this is going to be positive, so plus 6 is equal to 0. Right, now let's plug these numbers in. So b is just going to be 2. So 4 minus 4 AC, so 4 times a, which is going to be 1, and then times 6, which is going to be 6, so 24. So 4 minus 24 is going to be equal to negative 20, and that is less than 0, which means that there's no real solutions for that. That's how you do it through discriminants, and yeah. Also, by the way, these are some really quick, you know, common sense tips and stuff. If the equation is the exact same, right? So if y is equal to x squared, and then y is also equal to square root of x to the 4th power, right? These are the same values technically, right? They have infinitely many solutions because it's the same thing. But sometimes, you know, the teacher will make it like equal the same thing, but like look different and some bullshit. So make sure you simplify everything before you start. And also, if a quadratic has the same vertex, right, that means they only touch once, or, you know, infinitely many times. Now I'm gonna show you how to do it on a calculator, alright? So just go to y equals, right? Clear everything out type shit. Then just put whatever quadratic or linear equation that you want. I'll just keep it simple, x squared. And then the other one, you go down, right? And then whatever that is, 3x, alright? And press graph. And boom. Where's the other one? Boom. See that? Right? Now, if you want a better look, just zoom in, right? Hopefully I can see it more clearly now. You see how now it intersects at 2 points? Now, if we want to see the locations at that point, right? You can, if you want, you can like use this to like guesstimate it, right? However, it's much easier to just press second, trace, go down intersection, and then go to either side of the point where they intersect. And they intersect at 0, 0. And yeah, that should be about everything. Also tell me if I made like any mistakes. I need feedback. Bye bye.